enzyme, when it is changed, so this was the tobacco plant in which this enzyme was not changed. Here the enzyme is changed. It's clearly in the tobacco plant we have a better growth. This has been published. And calculations were made that if you change this enzyme, the plant will be better. And that was published before. The data was already in the literature. When calculations was made, the people didn't know the data. And then they could see that, yes, their predictions came true in tobacco. So there's another way to improve. But biggest emphasis, at least in Urbana, Illinois, is going on in a grass. It's a miscanthus grass. This is a hope for making bioalcohol. This is where the British Petroleum has put in its money. Of course, the money goes to all other research as well, because supposing it fails, then all the money is sunk in it. And of course, the company is interested because the idea is that if something happens, the company will have a royalty cut on it. And therefore, they have a reason to believe that, yes, it is good for us also. And the industry must go in where there is something for the industry in the future. So therefore, we have this support. It's a perennial grass, a very high efficiency and a long growing season. And it's being used in Europe as a biomass source. At the University of Illinois, they have begun to exploit this grass for bioalcohol. This particular student's picture seems as being everywhere. I don't know even her name. It's in many magazines, many journals, scientific journals. So another advantage of this miscanthus grass is simple, that it will not do the problem that Monsanto had once, putting something that was going to spread. It is not transmitted like this. They use the rhizomes of the plant to make other plants rather than the seed and rather than the pollination. So basically it's considered to be a safe plant. And maybe there are other plants. Of course in India, I don't have to tell you these things, you've already heard that Demon Fearless wrote in Nature, India has high hopes for jatropha as a biofuel source, but little is known about how to make it successful. So too many people are growing jatropha, but not enough research to see if a farmer, when he grows it, whether he is going to get a benefit or not, because some plants give bad seeds. So therefore tremendous research is needed in genetic engineering of this plant to make it such that it would be good. Now, at this time when Shatabdi ran from New Delhi to Amritsar, it was powered with biodiesel from the first time. Okay, but what happened? Nothing, not much happened. Now, just last month, and which company, Rajni? Continental flew an airplane, and they used half of their fuel quarter was jatropha and quarter was from another algae, cyanobacteria, maybe. And I have not read the paper yet to find which one they used, or maybe they won't tell us which one they used. But anyway, so it is really happening that biodiesel is being made and actually it's being used. So therefore I think future is good. And of course Pushpati Ghosh is already running his car. Oh, you know somebody there? and here is Adam Das in Delhi who's running his car. So basically I'm not saying that anybody should jump into it, but I think these are hopes, there are high hopes. And company D1 Oils has, when I read last time, planted 81,000 hectares in Chhattisgarh and Tamil Nadu, with plans for an additional 350,000 hectares. I don't know if this has happened now or not. I have not looked at it. So jatropha is one. And then we have a challenge. Here is a friend of mine, Madhuri Pakrasi, who works in Washington University in St. Louis. He works on algae, or rather I should say cyanobacteria. It's called cyanotc. And he is very sure. He just received a $2 million grant for going to find if cyanotc is going to be the one to make good biodiesel, and he's going step by step. So they're going to do genetic and metabolic engineering to increase photosynthetic efficiency, enhance biomass growth rate, increase oil content, but not necessarily in Sanothece. Improve temperature tolerance to reduce the expense of cooling the chambers where you want to grow. Algae decrease photoinhibition, that is, plants are actually growing in sunlight, they are being inhibited, and their rate of photosynthesis growth is decreased. And I think Prabhat has worked on this problem, and I have worked on this problem in plants to see what can be done about it, but we don't have any answers for practical. And you reduce the susceptibility to the damage. So basically, a lot of problems exist, and they have to be attacked, and they're being attacked. This is just a public sort of magazine, Scientific American. They have a nice picture that how from the cellulose production they have already thought about how ethanol will be made. And at the University of Illinois, we have the collaboration of Department of Agriculture Engineering, and even Economics Department is now in it, so that they should be calculating how much money is being used. For instance, they were calculating how much air conditioning, how much CO2 gas will have to be put in a field to do these experiments. So economists have to be involved in seeing whether it is feasible or not. And in New Zealand, there's Dr. Chisti. I don't think this is a slide from him, who was from India a long time ago. He's an engineer, and he's already growing cyanobacteria on a very large scale and already making biodiesel. But you know, these are all pilot plant experiments, nothing nothing commercial yet. Then the question of hydrogen that I brought up earlier. So here is a alga, green alga, Chlamydomonas hardii, and it was discovered long time ago that this can produce hydrogen. So all efforts are being made to make hydrogen from this alga, get the fuel cell, hopefully make electricity, or just use hydrogen. Whether this is feasible or not, the chemists are saying that the biologists, we learn from biologists, but we must do things in our lab so that we can not depend upon living things. And so, learning from the natural photosynthesis, the water and carbon dioxide, making oxygen and glucose, and learning all the details, the chemists have started to make in the laboratory systems that are dependent on the knowledge that we receive from here. And so they're putting all the components which we don't have to know at this moment, and trying to make, through this molecular device, from water, hydrogen and oxygen. This research is going on in many laboratories. Arizona State University is one of them, as well as MIT, as well as many other groups are attempting. So here is an attempt being made by my former student who is now ready to retire. He's 60 years old, 62 years old perhaps, Thomas Wierzynski in Arizona, in the Australian National University in Canberra. So what they did is that they took a protein called bacterioferritin, and they discovered that this contains natural cofactors, meaning thereby components, say they use a simple word, which is compatible with the system that produces oxygen and hydrogen. So this protein has been sequenced, meaning thereby we know every amino acid, how it is put together. They have a structure, crystal structure, just like that of photosystems we have, and they have shown that they can genetically manipulate it, and it can be produced in large quantities using E. coli, is one of the organisms microbiologists love, expression system. And using that, they have, but before that, I should tell you about this, that a group in Philadelphia, Les Dutton's group, they are also trying to make some enzymes, and these enzymes will what's called green enzymes, we call photosynthesis, chlorophyll, and will make oxygen from water. And then they are thinking is not only to make hydrogen, but to take nitrogen or make ammonia for fertilizers, CO2, and make methane for industry. So these are the dreams, and it's not total dreams, because there are experiments behind it, and there are pilot plants, or rather the laboratory where they are actually doing some